So let's begin these notes, 4.8. It's titled Quadratic Inequalities. And our learning target that's on the wall right there, it says, by the end of this lesson, I'll be able to graph and solve quadratic inequalities. So what do you need? What are the skills that you need to be able to graph and solve quadratic inequalities? Well, you need to be able to solve quadratic equations. Now, we know how to solve quadratic equations by factoring, splitting, and solving. Or maybe, worst comes to worst, you could use a quadratic formula, right? Everybody could use a quadratic formula. What other skill do we need? We need to be able to apply knowledge of inequalities to determine if your graph is solid or dotted. So if your inequality has a solid line underneath it, then it's going to be a solid graph. If your inequality does not have a solid line underneath it, then it's not going to be a solid, it's going to be a dotted graph, a dotted parabola or a dotted line. You guys remember that stuff, right? And yes, I did spell determine wrong. Determine. Okay. All right, and what else do we need? We need how to shade when graphing. We need to know how to shade when graphing. And how do we do that? We test a point, usually 0, 0. If it works, you shade in that side. If it doesn't work, you shade in the other side. Let's go back to Algebra 1, right on our notes. Let's begin by graphing this linear inequality from Algebra 1. Okay, now this already is in y equals mx plus b. So where does it cross the y-axis? 1. Everybody put a dot at 1. What do I do from there? Do I go up or do I go down according to our slope? Down how many? 2 and over 3. So I'm going to go down 1, 2 over 1, 2, 3. Let's put a dot right there. And you could continue to go down 2 over 3, but you'd be off. Or you could use that pattern backwards to extend it the other way. Instead of down 2 over 3, go over 3, up 2, over 3, up 2, and put a dot right there. Now, the question is this line solid or dotted based on this inequality? Dotted. It's dotted. If it had a solid line underneath it, yeah, I would do a solid line. If it does not have a solid line underneath it, it's going to be a dotted line. So everybody do a dotted line right through those points. That's kind of dotted. Erase a couple. All right. Anyway, now the final touch is to shade, because the shading is where your true answers are represented, right? So your answers are either going to be down here or up here. Now, I know we know shortcuts, but for the sake of relating it to what we're doing today, let's actually test the coordinate 0, 0. Okay? So when I test 0, 0, I plug in 0 for x, 0 for y. I have a 0 here, a 0 there. It's going to say 0 is less than 1. What do you say about that? Is that true or false? True. So this point down here does work. It is an answer. That means that all my answers are down here. So go ahead and shade in everything on this side of that dotted line. And the fact is, any point down here will work. If I select any xy value and plug it in, it's going to give me a true statement. Anyway, that was pretty easy. And today we're going to be graphing quadratic inequalities, and it's the same exact process, right? You treat it like if it were an equation. But before drawing your parabola, you got to decide if it's solid or dotted, and then you got to shade by testing a point. So let's jump right into this quadratic. Let's pretend it's an equation. If I wanted to graph this equation, imagine it was an equal sign. How would you graph this thing? Where would you start? Start with your vertex, right? Wouldn't you start with your vertex? And how do we find the vertex? You use the vertex formula. X equals negative b over 2 times a, which means negative parenthesis over 2 times parenthesis. The b value happens to be 2. The a value is 1. The c value we don't even care about. It's not in this formula. So you have a 2 right here and a 1 right here. So that's really negative 2 over 2, which means that the x value is really negative 1. Are you with me? So the vertex x value is negative 1. We need the y value. How do we find the y value? Plug it in. So let me rewrite my equation. Even though it's not an equation, I'm pretending it's an equation. X squared plus 2 times x minus 3. And I am plugging in the negative 1 right in there. So I will get 1 minus 2 minus 3 when I do the math. So 1 minus 2 minus 3, what's the answer? Close? Negative 4. Okay, 1 take away 2 is negative 1. Negative 1 minus 3 is negative 4. That's the y value of our vertex. That is the most important point. Let's all graph that most important point. Negative 1, negative 4. That's down here. What do we do next after plotting that point? Axis of symmetry before anything, right? Axis of symmetry. That's technically the axis of symmetry equation, x equals negative 1. But anyways, that'll provide you a reflection line so it can make graphing twice as fast. So yes, because the A value is 1, you guys were saying that we could use the pattern 1, 1, 2, 4, 3, 9. So because A equals 1, we could use 1, 1, 2, 4, 3, 9. Again, this is a pattern. These are not coordinates. It's just a pattern from the vertex. So I need to understand that this parabola is opening up. So I'm going to go 1 over 1 up and put a dot right there. And then I'm going to go back to the vertex and go 2 over 4 up. 2 over 4 up and put a dot right there. And go back to the vertex, go 3 over 1, 2, 3, 9 up, which will be right on the edge. If you count that, be right on the edge. And all you got to do now is map them over to the other side of your axis of symmetry, reflect it over to the other side of the axis of symmetry. Now, before I draw my parabola, I need to determine, is this parabola going to be solid or dotted? Based on this inequality, there is no solid line underneath it, so it's not going to be solid. It's going to be a dotted parabola. Everybody please do a dotted parabola right through these coordinates. Now we still need the finishing touch. The finishing touch is actually showing where all the answers are at. And on an inequality, you're talking about either one side or the other side. Since this is a U-shaped curve, it's either going to be on the inside of the U-shaped curve or on the outside of the U-shaped curve. How do we figure out where our answers are at? Testing a point. And the easiest point to test most of the time is 0, 0. So if we test 0, 0, which is that yellow dot clearly on the inside, if it works, I shade in the inside. If it doesn't work, then the answers are on the outside, right? So let's test 0, 0. All you got to do is plug in 0 for y, 0 for x. So it's going to say 0 is greater than 0 minus 3. That's going to say 0 is greater than minus 3. What do you say about that? That's true. So this is a point that works. It is a solution. That means all my solutions are on the inside. So let's shade in the inside. You know what? I want to highlight the inside in yellow. So I'm shading in the inside. Cool. And that's it. Pretty easy, right? Graphing straight up. It's just like graphing a parabola, but instead of drawing it solid, you got to determine if it's solid or dotted by looking at your inequality. And then you got to test a point to see where your answers are at. They're either on the inside or the outside. Okay, so this is where it gets a little funky. If they ask you to solve a quadratic inequality, you could use the graph to state your answer. So for example, notice guys, I'm giving you a quadratic inequality right here. Now this is not a function. There is no y equals. But what I'm saying is this inequality is related to this graph above. After all, if I told you to look at this original quadratic trinomial function and I told you find the x-intercept values, what would you do? You would set y equal to 0, right? So if you put a 0 right there, it would say 0 is greater than that stuff. And if we look at what they're showing us down here, it says 0 is greater than that stuff. So it really is, this graph is really represented with this quadratic trinomial. The only difference between the function that has this y right here and this one that has no y's is that you're not on an xy plane. You're only talking about real x values, okay? Real x values. So we could use the graph to determine where our real x values are. So check this out, guys. If I asked you, is x equals 3 an answer to the inequality? What would you say? No. Is x equals 2 an answer to the inequality? No. Is x equals 1 an answer to the inequality? Not really, because it's a dotted graph, so you can't include it. Does that make sense? Is this an answer? Yes. Is this an answer? Yes. Is this an answer? Yes. This an answer? No, but anything on the inside of these x values. Okay, so what I'm trying to say here is because there's no y on this inequality, you could think about the graph and just focus in on the x-axis only, on the x number line only. So you know that it's between here and here. All of your answers are in here on the x number line, right? How would we write that? We would write that as a compound inequality with the smaller number on the left side, the bigger number on the right side with x in the middle with the appropriate inequalities. Less than in between those. So take a moment and think about that. If your inequality is not, it's not saying graph it, if it's just saying solve the x inequality, then you could look at the graph and just focusing in just on the x's and see if your answers are together or apart. If they're apart, you're going to write them apart with the word or. If they're together, you're going to write them together as a compound inequality with x in the middle, smaller number on the left side, bigger number on the right side. This is all stuff that we've already done before. I hope we understand it. What do you think? Okay, if you kind of understand, that's great. It's the first time you see it. Don't freak out. You need to see a lot more. So please pay attention here, guys. This is not easy stuff. If you're paying attention, it will be easy. So, right here I explained that based on the graph that we just did, the answer is -3 and x is between -3 and 1 with those inequalities. Let's take a look at this next one, example 2. If I told you to solve this quadratic trinomial inequality, there's no y's involved, right? But that would be the same thing as graphing this quadratic trinomial inequality. And if I did graph it, it's already graphed for you. It would be shaded on the outside. That means I tested 0, 0 and it didn't work. I shaded everything on the outside. My answers are on the outside. So this is already graphed for you. It's not like you have to graph it. It's already graphed for you. But what I'm asking you to do is to use this graph to see what the answers are to this quadratic trinomial inequality. Okay. Now, since there's no y's involved, you're not going to be looking at the xy plane. You're just going to be looking at the x number line, just the x number line. So let me ask you this. On the x number line, is an answer 4? Could x equal 4? Yes. Could x equal 3? Yeah. Yes. Could x equal 2? No. Based on this graph, no, because it's shaded on the outside. So if you're just wanting the inequalities of x, you're going to look at the x values, which is going that way, and from here that way. Okay, now it's obviously a decimal, right? It's in between 2 and 3. It's in between 0 and -1. So right here it says, according to the graph, the answer is, and I think on your paper I put approximate. Is that right? Yeah. Okay, so let's just give a rough idea of what that decimal is. So what would you say, 2.5 or a little bit less than 2.5? A little bit less, 2.3, 2.4, right? Okay, so if we go, let's say this actually represents x is greater than, let's say 2.4. X is greater than 2.4. And this other one over here is x is less than -0.4, right? So x is less than -0.4. And all we do is put the word or right between them and we're done. So instead of doing a bunch of algebra, what I'm going to want you to do is to think about the graph to be able to determine your x values when you're solving quadratic inequalities. Okay? Now, if you wanted the exact decimal values, you'd have to use the quadratic formula. It'd give you your two answers. And of course, you'd have radicals, which means you'd have irrational decimals, which are pretty crazy. But anyway, let's look up here at this next example. This one blows people away. Why? Because according to this, like this graph, it's already graphed for you, right? The shading is on the outside. And this inequality is directly related to this parabola, this inequality that we graphed. So using the graph, what's your solution if you just want to focus in on your x values? Anybody? All real numbers is correct. Now, some people would say no solution, right? Because we're so used to thinking, oh, the parabola's up here, it doesn't cross the x-axis, no solution, right? But we're talking about inequalities here. The areas are your answers. So you're talking about all of this being shaded. So when I ask you, hey, look at the x values, just the x number line, where is it shaded? Is it just from here that way or just from here that way? No, it's everything's shaded on the x. So what do we say? X equals all real numbers, according to this graph. So let's write that down. X equals all real numbers. Now, that really does, I mean, if you're doubting it, like you're saying, I don't buy that. What do you mean x equals all real numbers? That means that you can plug in any number you want in here into this inequality and do the math, and it's going to work. If I plug in 0, 0 squared plus 4 is 4, and 4 is greater than 0. If I plug in -10, -10 squared is positive 100. 100 plus 4 is 101. That's greater than 0. Any number you plug in is going to work because of the shading that's on the outside. Okay, so because we're cramped for time, we're going to kind of deviate away from the algebraic way of solving. We're still going to use algebra, but I want you to think about sketching the graph so you could understand where your answers are at. We're going to do step 1, solve it as if it were a regular equation. You could always factor, split, and solve. You could use a quadratic formula to get your answers. And then step 2, when you get your answers, plot them on the number line, the x-axis. After all, the answers are x-intercepts. So you're going to plot them on the x-axis, and this is where I want you to sketch your graph. So you could test a bunch of different values to see where your answers are at, but instead of going this way to number 3, let's do 3 right here and just say sketch and think. Sketch and think. Everybody write that down right there. For number 3, let's write down sketch and think. So let me show you what I'm talking about here. Number 1, if I wanted to solve this, let's pretend it was an equation. What would I do to solve this thing? If it had an equal sign, what would I do to solve this thing? Subtract 14. Subtract 14. Let's rewrite it. You're going to have to write really tiny. I apologize. X squared minus 5x minus 14. I'm going to pretend it's an equation. Okay, so at this point, for me to solve, I could use the quadratic formula. But if you could see an easier, quicker way, a better tool to use, please use that better tool. What could we use here? We could factor, split, and solve. What times what is negative 14? The c value that if you combine together is the b value. Negative 7 times positive 2. And now we could apply the zero product property. X minus 7, that could be 0. X plus 2, that could be 0. Which gives us our two answers, x equals positive 7 and x equals negative 2. Any questions so far? That would be great if this were an equation. I'd be done. But the problem is it's not an equation. It's an inequality. And in inequalities, you have a whole area of answers, not just two specific answers, right? So what we need to do here, on the instructions it says test, but what I would like you to do is to draw your x-axis, your x number line, plot those points, those answers, plot them. So let's put a negative 2 over here and a 7 over here. Where would 0 be at? It would be in between them, right? 0 would be somewhere in between them. So I'll put the 0 right there. Now, does this parabola, does it open up or does it open down? Imagining that it were a graph. It opens up because the a value is 1. Are you with me? Okay, so if it opens up, and we know that these are the answers, the negative 2 and the 7, those are the answers, and it's opening up, that means that the vertex is somewhere down here, right? So this is what I want you to conclude. Analyze your a value, analyze your quadratic equation. That way you could sketch. So your parabola, by the way, this is not a solid parabola if you were graphing it, so I want to do a dotted. But in reality, it doesn't really matter. All I want to show is a sketch. That way, when I think about the shading, I'll know if I need to write a compound inequality or separate inequalities. Does that make sense? So sketching it, I would have my y-axis right here, my x-axis right here, my answers right here. I know it's opening up. So I need to see where I shade. Do I shade the inside or do I shade the outside? That's the question. Do I shade the inside or the outside? How do I do that? I test a point. What test am I going to point? What test am I going to point? What point am I going to test? 0, 0. So if I plug in 0, 0, plug in 0 everywhere, plug in 0 for the x's, actually to the original, I'm sorry, plug in 0 for the x's, 0 squared is 0, 5 times 0 is 0, 0 take away 0 is 0. Is 0 greater than 14? No. So does this work? No. So are you going to be shading the inside? No. You're going to be shading the outside, right? So let's shade in the outside. But you see, this is just a sketch. The only thing that really matters is that you understand that your inequality is going to be right here at negative 2 going this way, and right here at positive 7 going this way. So because the areas are apart, you're going to write your inequalities apart. X is less than negative 2, or x is greater than 7. That's your inequality that has to be written apart with the word or, because if you just focus in on the x values, not the whole xy plane, but just on the x values, we shade it in the outside, which means the answers are apart from each other with the word or. Yay? Okay. How about number 2? How would you solve that? Again, pretend it's an equation. What would you do? You could always use a quadratic formula. Is there a quicker way of doing it? Factoring. Put the x. What times what is 2 that if you combine together is -3? -1 and -2. That'll give you a +2 if you multiply them, and it will give you a -3 if you combine them. We are pretending it's an equal. We're going to use zero product property to separate. We get our two answers. X equals 1, x equals 2. Those are your two answers. What do I do next? Go to the x-axis, right? We're going to sketch. So go to the x-axis. Plot those values. Here's 1, here's 2. Where would 0 be at? Inside or outside of those two values? Outside would be over here, right? 0. Okay. Does this open up or down just to sketch it? Up. So these are my answers. I know it's opening up, so the vertex has to be down here somewhere, right? So let's just sketch that. Again, this is by no means accurate, but we just want the sketch so we could determine whether we shade the inside or the outside, which will tell us if we write it as a compound inequality written together or a compound inequality that's separate with the word or. So I need to test the point. What point am I going to test? Yeah, if you're looking at the sketch, test 0, 0, which is clearly on the outside. 0 everywhere. 0 for x's, 0 squared, 3 times 0, that's going to be 0. Plus 2 is 2. Is 2 greater or 2 less than 0? No. 2 less than or equal to 0? That is a no-no. So this point right here, it did not work. No. So where am I going to shade? The inside. The inside. You're going to shade everything on the inside. So our quadratic trinomial solution right here is going to be between here and here. So you're going to write it as a compound inequality together. So you put x in the middle, smaller number on this side, bigger number on that side, with the less than or equal to's right in there. So I hope this makes sense. We're going to be sketching the graph, analyzing the graph based on what we know with regards to A, and testing points to see where we're shading. So let's take a look at number 3. Number 3, let's try to do it. This one's interesting. That's why I put it on this class opener. We could factor, split, and solve. Let's pretend it's an equation equal to 0. What times what is 1 that if I combine together is 2? 1 and 1, right? And when I split it, I'll get two answers. Actually, one single answer, -1 and -1, right? Yes? So what does that mean visually? If I drew a sketch of my x-axis, my answer is at -1. That's where it's going to cross the x-axis. Where's 0 at? Is it on the left side or the right side of this -1? Right. It's on the right side. Okay, so put a 0 right there. And we might as well just sketch the y-axis right through it, just for a sketch. Now, does this parabola open up or down? Opens up. Okay, it opens up, and it only touches at one spot. So what does that really mean? One solution only, right? There's only one solution. We got only one answer when we solved it, but it is opening up. So if I wanted to just sketch this parabola, is it going to be a solid parabola or dotted parabola? Dotted. Okay, so let's just quickly sketch. I mean, you could be accurate if you wanted to by using the pattern 1, 1, 2, 4, 3, 9, but that's not what this is about. Right here, what this is about is simply stating where your answers are at. So we're thinking about the graph to determine whether we're shading the inside or the outside of the parabola. So what value would I test to shade? 0, 0. So if I plug in 0 for x, you'll get 0 plus 1. That's going to be 1 is greater than 0. Is 1 greater than 0? 1 greater than 0? Yes. So 0, 0, yes, it works. So I'm going to be shading the outside, right? So you're shading everything on the outside. And we don't need to think about the whole xy plane. We just want to think about the x number line. What would that be? All real numbers. However, it cannot equal -1, because if the parabola is dotted, that means that you cannot include that value where it touched. So it cannot be -1. So you're going to say x equals all real numbers, but x cannot be -1. I know that's a very interesting problem, right? Now, if this would have been a solid parabola, then you would include it, because a solid parabola would include it. It'd be an or equal to. If you're still doubting and you're thinking, wait, that doesn't really make sense, it's simple, guys. If I plug in a -1 right here and a -1 right there, it will not work. -1 squared is 1. 2 times -1 is -2. 1 minus 2 is negative 1, plus 1 is 0, and 0 is definitely not greater than 0. 0 is not greater than 0. So that's why x equals all real numbers, but x cannot equal negative 1. Number 4. Ladies and gentlemen, if you tried to factor, split, and solve, you wouldn't be able to do it. Okay, so what do we need to do to solve this quadratic trinomial equation? Quadratic formula will answer any quadratic inequality. Of course, try to factor, but you can't factor. When you start thinking what times what is 7, that if you add together is 5, it doesn't work. So we have to rely on the quadratic formula. When you use the quadratic formula, use parentheses instead of the variables. And of course, identify your A is negative 1, your B is 5, your C is negative 7. So your B is 5, plug it in right there and right there. Your A value is negative 1, plug it in right there and right there. And your C is negative 7, plug it in right there. Now you always begin with your discriminant. So you go 5 squared, that's 25. Negative 4 times negative 1, that's positive 4, times negative 7, that takes you back to a negative 28. So you have 25 take away 28. So your answer so far is negative 5 plus or minus the square root of negative 3 over negative 2. Now what happens when you do the square root of a negative? Imaginary, right? So if we start, we could stop right there. It's not asking us to actually find the answers. It's asking us well, it is asking us to find the answers, but it's an area of answers. So we could stop right there, because when you get imaginary values, what do you know about the parabola and the x-axis? It's not going to cross, right? When you end up with the imaginary values, you're not going to have answers on the x-axis. It's not going to cross. Solutions are x-intercepts, so it's not going to cross the x-axis. Now, does this open up or down? Down. The parabola opens down. We know that the answers are imaginary, which means it doesn't cross. So let's just sketch a parabola somewhere down here. Yay? It doesn't have to be accurate, because all we care about are the x values on the x number line. So it doesn't matter where you put your x, your y. There are no answers. They're imaginary. So we need to test whether we shade in the inside of the parabola or the outside of the parabola. All right? So what value would you test? 0, 0. So let's plug in 0 right here. 0 squared plus 5 times 0, that's 0. 0 minus 7 is negative 7. Negative 7, is it less than or equal to 0? Yes. Negative 7 is less than or equal to 0. That's true. So that means that the origin 0, 0 is true. It works. So we're going to be shading in the outside, right? So when you shade in the outside, that's thinking about the entire xy plane, the entire graph. Let's just focus in on the x values on the x number line. What are your answers? All real numbers. All real numbers. So x equals all real numbers. That's your answer for that quadratic equation. So whenever you're doing the quadratic formula, if your discriminant is negative, you're going to end up with imaginaries, which means that your parabola does not cross the x-axis, right? So at that point, you're either going to have all real numbers or no solution at all, right? Because it's either going to be out here or in here. So you could, if you wanted to, even test any point on the x-axis like we did. 0 is the easiest one, and see if it works. If it works, then all of them are going to work. If it doesn't work, then none of them are going to work, because they're all going to be shaded in here, which means there is no solution. I think number 5 is another one of those examples with imaginary values. Focusing in on number 5, it's already ready to plug into the quadratic formula. The b value is 4, so plug in a 4 right there, 4 right there. The a value is 1, so plug in a 1 right there and a 1 down there. The c value is 5, put the 5 right there. Let's work on this. 4 squared is 16. 4 times 1 times 5 is 20. 16 minus 20 is a negative number. So what do we have so far? We have negative 4 plus or minus the square root of negative 4 over 2. We already know it's going to be imaginary. So we could just stop right there. If we wanted the actual answers, yeah, you would keep going. Negative 4 plus or minus 2i divided by 2, which would be negative 2 plus or minus I. That'd be the actual exact answers if they were asking for exact answers. But they're asking for the area of answers, right? So let's not worry about that. Let's just say, because we know it's imaginary, we know that when we look at the x-axis, the parabola is not going to cross the x-axis.
So on the test, so we put that? That's the answer.
The plus or minus I, that's not the answer, because this is not an equation. There's a whole area of answers, and we're talking about just the x values. Guys, because we know because we know that the a value is positive, we know it's opening up, and because we know it's imaginary, we know it's not going to cross the x-axis. So you could just sketch any parabola that's anywhere up here. Now you want to test the value to see if you shade in the inside or the outside. So let's test what value? 0, 0, which is clearly on the outside. So when you plug in 0 everywhere, 0, all this is 0, plus 5 is 5. Is 5 less than 0? No. So this does not work. 5 is not less than 0. It does not work. Where are your answers at? In here, inside the parabola. And again, it's just a sketch because all we care about are the x values. So what are our answers on the x-axis? None. So what do we say the answer is? No solution. You could write the symbol, or you could actually write it out.
How do you know where to put the parabola?
How do you know where to put the parabola? Great question. Now, because it's just a sketch that we're using to determine what our actual x answers are, it doesn't really matter. All I need to know is that when I end up with a negative in here, it's imaginary, which means it's not going to cross. So at that point, it's either opening down here, not crossing, or opening up here, not crossing. And it doesn't matter if you put the parabola over here, or way up here, or just slightly above it, right? It doesn't matter where. But we do know it's opening up, so it's going to be up here somewhere. And if it's up here somewhere and you test 0, 0, it's clearly going to be on the outside of the parabola. So yeah, this is definitely nowhere near accurate, but we're just using what we know about parabolas to determine what those x values are. Great question. So we're going to be working on a homework assignment that has all these questions on it.